So you will have solved by graphing, which means I check to see, did you get your y-intercept right? Or if you graphed by intercepts, did you get your two intercepts correct? Did you get your slope correct if you did slope-intercept? So if it's given to you in slope-intercept, you probably want to do it. I know this gives you some that aren't in either. On your test, it'll either be in slope-intercept or standard form. So one or the other. If it's in slope-intercept form, it's easiest just to graph that way. Start at your 4. Your slope is positive 5/3. Remember, a positive 5 over a positive 3 will move the same as a negative 5 over negative 3. Because if I go up 5, I'm going off this graph, right? And so for this one, I would go down 5 and left 3. And that would also be a positive slope. So you can do it, you know, if it goes off the graph, you're going to want to move a different direction. Just make sure that when you graph it, you can see this is a positive slope because it's going up. That second one, negative 2, I can go up 1 and left 3, which actually puts me right there on that crossing. Or you could go down 1 and right 3, because a negative 1 over a 3 or a positive 1 or over a negative 3, that is the same movement as well. And you can walk these. So if you can't tell exactly where it's crossing, what I mean by walk is you can walk your slope. Keep going up 1, left 3, up 1, left 3 until you get there if you need to. And you can see that this crosses at negative 3, negative 1. All right. All right, for this one, on the quiz review, I have solve by substitution and solve by elimination. On your test, I'm actually just going to say solve the systems of equations, and you are welcome to solve any way you want other than graphing, all right? So you do need to solve algebraically, but you can solve either by substitution or elimination on your test. There are some that lend itself to an easier way of solving. By that I mean, even if I didn't tell you to solve by substitution, this one would probably be easier to solve by substitution because you already have a variable by itself. Does everybody see that? And so for this one, I would probably go ahead and just solve by substitution. Put that negative 5x plus 9 in there. Solve for my x, and then plug it back in to get my y, right? Because it's set up to naturally solve by substitution. But if I got something like number 13 and it didn't tell me how to solve, I would probably solve this one by elimination, because clearly I have a y that is ready to be eliminated, right? Positive 4, negative 4. Does that make sense? And so getting a variable by itself here would be way more difficult. I'd end up with fractions. And so if I had it like this and it didn't tell me how to solve, well, I would just solve by elimination. Add down. Those would cancel, right? And then you can go ahead and solve for your x is 6, plug it back in and get your y, right? And then you're going to have some like this. This is actually set up to solve by elimination as well. There's two things you can do here. I want to show you both because I want you to start recognizing maybe some shortcuts that you may not see. I could multiply this second equation by 2, right? If I multiplied by 2, I get a negative 6 and a positive 6. Does everybody see that? Then I could add down and eliminate, and I would get my y value and plug it back in. Or all of these are divisible by 6. Does everybody see that? So if I divide this by 6, I get negative 1x. If I divide this by 6, I get positive y. And if I divide this by 6, I get negative 2, right? What's everything in the second equation divisible by? 3. If I divide this by 3, I get positive x. If I divide this by 3, I get 3y. And if I divide this by 3, I get 10. I have a negative 1x and a positive 1x. You can multiply equations or divide equations as long as you divide every single one of them or multiply every single one of them. Both of those methods would work. Multiplying the second equation would eliminate my x, or dividing out the common factor of those two equations would also eliminate my x. Does everybody see that? And so there are multiple ways to solve these. They will both work. One way will make the numbers a little bit smaller, right? And the other way just will make them larger. But when you get down to your final division, you will get the same answer for y when you do this one, okay? So just something to think about when you're doing these, that see what is the easiest method to solve. That's what I'm wanting you to do on the test. What's the easiest method for you to solve? But if there is a method that you naturally go to and you always want to use, you're welcome to, okay? So make sure that when you're doing these that you graph each line, exactly how you're going to graph, decide if it is solid or dashed, shade, and then make sure you fill in where they cross so that I can see that. If you have a vertical or a horizontal line, you're going to have X, like this guy, -2, and that's going to just be a vertical line. Or Y, -2 would be a horizontal at -2. All right. So if you have just one variable, then you will have a vertical. And so then greater than for X would be the positive direction versus the negative direction, right? Less than for Y was above or below, depending on less than or greater than. So for these, I would recommend either colored pencils or a highlighter. It's just my recommendation, okay? The reason I recommend it is it makes life a little bit easier when you start walking through these problems. So if I were doing this problem right here, I'm going to concentrate on setting these equations up first. And so if I look and read through this whole problem, at the very end, you see that it says how many bags of food should be consumed in order to meet the minimum requirements of this at a minimum cost, okay? And so you can see that he's trying to minimize his cost, all right? I actually put here cost equation to minimize, right? So we are going to look first at everything that has to do with cost. So this is where I do my highlighter. I'm going to highlight this guy in the green or whatever this is here. And then I'm going to highlight anything that has to do with cost. X costs $10, Y costs $12. And so that tells me my cost equation. 10x plus 12y equals my cost. All right. And then I'm going to look at my limitations, okay? My limitations, if you read through it, he has a minimum daily requirement of proteins, minerals, and vitamins. And so that's why this has proteins, minerals, and vitamins set up. And so I'm going to look first at proteins, and I'm going to say, well, let's look at everything that has to do with proteins. I have 40 units of proteins in that food and 30 units of proteins in this food. And I need a minimum of 150 units of protein. That's one of my limitations. You'll notice your cost equation only had 2, right? It didn't have 3 different things talking about it. Your constraints will have 3 things, right? It'll usually have this, and it has to be within this, right? Or it'll at least tell you between these 2, and that's a limitation. But your cost or your profit will just tell you one thing about each of those pieces, okay? And so now I'm going to set up an inequality for this. 40 is what my X is. 30 is what my Y. And a minimum means I want at least 150. So while profit usually minimizes something, meaning it's a limitation, like a lower limit, this is actually a higher limit. I actually want it to be at least 150. So I want this guy larger than 150 if possible. Okay? And then I am going to look at my next group, minerals. And so I've done proteins. I'm going to look at anything that has to do with minerals. And so I'm going to say, well, X has 20 units of minerals. Y has 20 units of minerals. And I need a minimum of 90 units of minerals. And so that's going to be my next one. My 20 X's and my 20 Y's at minimum needs to be 90. And then I'm going to look at my last one, my vitamins, and do the same thing. X has 10 units of vitamins. Y has 30 units of vitamins, and I want a minimum of 60. That's my last equation. 10 for X, 30 for Y, a minimum of 60. Okay? And so this is why I tell you colored pencils are highlighters. And I would even recommend when you graph these, even if you graph them in a pencil, maybe highlight that line in the color that you highlighted, because you're going to have to go back and figure out where they crossed, okay? And so you're going to have to go back and figure out where proteins and minerals crossed, or where minerals and vitamins cross. And so if you've highlighted your lines, then it'll tell you which 2 equations to use to figure out where they cross. Because you're going to want to go back and use one of your methods here. And typically I use elimination to figure out the X and Y where they cross, right? And once you've graphed this, all of your points, your vertices at the end of your shading, You're going to find out where it hits the X and Y axis, where the lines themselves cross, right? And then you're going to take all of those X's and Y's and plug them into your cost equation for this guy, your cost equation. We want to minimize cost. So you're going to see which of those 4 points that you end up getting here give you the least amount of cost for this food. And that's going to be your answer. You're going to say this number of X food and this number of Y food will give me a minimum cost of this, okay? And so that's how you're going to do these. All right, 3 variables. For 3 variables, you're going to do what you did on the prior sections. You want to solve by elimination here, okay? For this first one, I'm going to look across here and say, what's the easiest variable to eliminate? There's actually 2 that are easy to eliminate here. Your X's and your Y's are pretty easy to eliminate, okay? So if I were doing these, I would probably do the first and last equation. Why do you think I'd do that? I have a negative 3x and a positive 3x, right? So I would do elimination with these guys here. This actually eliminates 2 variables, by the way. All right. And then I would take these 2 and eliminate. Why do you think I do that? Well, I have a negative 3x and a positive 3x, right? All right. And so I would take those 2. And I would do elimination with these. I will say this first guy is going to eliminate your X and your Z. The second guy is just going to eliminate your X, but you will have 2 variables. So if I were to do this one, these 2 would both eliminate, right? Negative 3x, positive 4z, negative 4z. So I have 2y equals negative 2. I already know what y equals. What does y equal? Negative 1, right? Then when I do this next one, these eliminate. Y and y give me 2y. Negative 6 and positive 4 give me 2z. Negative 3 and negative 1 give me negative 4. What can I do with that y? I already know what it equals, don't I? So just plug it in, right? Take this negative 1 that I already figured out and plug it in. Solve for z. Once you know your y and your z, go back up here to any one of these equations and plug in your y and z to get your x, right? So these look daunting, but they're really not, all right? I just want to show you the next one because you actually already have one eliminated. So look at this next one. This top equation has an x and y, and these 2 have x, y's, and z's. So while your y might be easy to eliminate in those 2, I would actually eliminate my z because I've already got one gone in the first one. I only have to do it once, all right? And so I would actually multiply this guy by 2 to eliminate my z. I would say negative 2x plus 5y plus 4z equals negative 9. And then 10x minus 10y minus 4z equals negative 6. And get rid of my z. Because then I would have an x and y here and an x and y here, and I could do elimination just to get rid of one of those. Okay? So you're just taking it one step at a time. Once you get a variable, plug it back into the next guy to get the second variable. Plug those 2 into the one above it to get your third variable. And so your answers here will always be an x, a y, and a z as an answer. All right?